A permutation is a number of ways of selecting and rearranging objects. The order in which the object is picked is random. Well, is it? The order in which the objects, maybe that's what it should be, the objects are picked is random. Oh, sorry. The order in which the objects are picked is important. That's what I want. Order is important. The combination is a number of ways of selecting objects randomly. That's what I want. Order is not important in a combination. Okay, so if we have three students, A, B, and C, how many different ways are there selecting a president and a vice president? And this time we want to list the possibilities. So there is 6. And so again, you're making 2 decisions. You're making a president and a vice president decision, and you have 3 and 2, which gives you 6. So for instance, if you get picked first, so if A gets picked first, that person's the president, and then B is the vice president, whereas B being picked first is the president, and now A is the vice president. Do you see there's a difference? Okay. A and C, C and A, B and C, C and B. So does everybody see the 6 different possibilities? So now I'm going to change the question and say how many different committees of 2. Does everybody see the order is not important? If I say 2 random people are in a group, it doesn't matter if I pick them first or last. They're still in the same group, right? So for instance, A and B, it doesn't matter if it's B and A, they're in just one committee of 2, right? A and C, again, it doesn't matter if it's C and A, and same with B and C. So there's 3. Because order is not important. So now it's going to get tricky. You got to have to figure out, is it a permutation or a combination? If you can put blanks down, it's a permutation, because that means there's order to it. Okay, so this is on your formula sheet. NCR, also written as C with a bracket N comma R, or these brackets like this. Or you could start with a permutation and divide the order out of there. Anyways, it's equal to N factorial over N minus R factorial. That's the permutation formula, but it has the additional dividing the order out of there. So if I go back to this question, if I did this as a permutation, I would get 3 factorial. If I divide the order that 2 objects can be arranged and divide that out of there, do you see I would get 3? Okay, so from a group of 5 students, 3 will be chosen to work on the dance committee. So let's list all possibilities. So we're going to start with an A. So 3 are chosen. A, B, C. A, C, D. A, B, D. Yes. A, C, E. A, D, E, and what's my last one? A, B, and E. Okay, so we got all the ones that start with an A. How about starting with a B? Remember, these are committees, so the order doesn't matter. So I can't say BAC because I already have ABC. Does that make sense? So B, C, D, we don't have. B, C, E, we don't have. And B, D, E, we don't have. And the one with the C, C, D, E. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's calculate it using combinations. So we have 5 we have to choose from, and we need to choose 3. So we're going to use the formula to calculate it. So how does the formula work? It's n factorial, so 5 factorial divided by 5 minus 3, so 3 factorial. And then I have the additional 3. Sorry, I didn't subtract that right. That is 2, yeah. 2 factorial, 3 factorial. So if I simplify this, say I choose the 5 factorial over 3 factorial, that'll simplify. I get 5 times 4, and then the 2 factorial would be 2. So do you see I get 10? Same way I did when I listed them all. Yes? Okay, how about 10 choose 6? 10 choose 6. So let's find this on our calculator for this one. Does everybody know where to go for your calculator? So did you get 210? And did you get 10 choose 4? What'd you get for that? You got 210. Why would you get the same answer? Yeah, so remember 10 choose 6 is 10 factorial divided by 4 factorial, 6 factorial. And 10 choose 4 is 10 factorial divided by 6 factorial, 4 factorial. And do you see this multiplication at the bottom? It doesn't matter which order you do it in, right? So that leads us to some certain properties for combinations. So NCR is equal to NCN minus R. So for instance, if I had 11C7, what would that be the same as? 11C4, yeah. Okay, how about this one? NC0 would be the same thing as NC, what? Nobody can tell me? Yeah, NCN. And what would that equal? I heard 1. That is correct. Again, the same reason why, yes, the last example, why was 10C6 the same as 10C4? Well, when you subtract it, it's equal to the other one, right? Okay, so what would 10C0 be the same as? 10C10, and what would that equal? 1. So anytime you see a combination and they're the same or the 0, you know it's 1. Now, does everybody understand why it's 1? Like if you plug it in the formula, they all cancel, yes? Okay, next one. NC1, that would be equal to NC n minus 1. Does anybody think they know what that would equal? It would equal n. Very good. And I'll show you why. So NC1 would be n factorial divided by this minus this would be n minus 1 factorial and then 1 factorial. Do you see when you simplify that, you get n, right? So 12C1 is the same thing as 12C11. And what's that equal to? 12. Okay, so what would 500C400 be equal to? Well, that would be the same thing as what 500C100 would be, right? So if I divide the two, what would I get? One. They're the same thing, right? 5C4 and 5C1 are the same thing, right? Or 500C400 and 500C100, they're the same thing. This, we just went through this. If you subtract, what's 500 subtract 400? 100. So if I put it in here, it's 500 factorial divided by 100 factorial 400 factorial divided by, what would this be? 500 factorial divided by 400 factorial 100 factorial. It's the exact same thing, right? This is a 1-mark question on the provincial exam a couple years ago. Okay, 9C3, what would that be? Well, that would be 9 factorial divided by 6 factorial 3 factorial. So let's simplify that. What would that be? 9 times 8 times 7, and then the 6, 5, 4, 3, 2, 1 would cancel. And then I'm left with 3 times 2. And I could put a 1, but who cares, right? So 3 goes into 9 3 times, 2 goes into 8 4 times, and we have 12 times 7, or you could have 21 times 4, 84, yes? What's 3C3 equal to? That would be the same thing that was up here, right? 1. You don't have to figure it out. Okay, 8 factorial over 5 factorial, 3 factorial. What would that be? So that would be 8 times 7 times 6, and then the 5, 4, 3, 2, 1 would cancel. And then the 3 factorial would be 3 times 2, which is 6, so cancel the 6. So we get 56. Okay, how about 6, 2 like that? Huh? So if we look back to the formula for combinations, do you see you can also write it like that, right? So this would be 6 factorial over 4 factorial 2 factorial. So that would cancel to be 6 times 5, and the 2 factorial would just be a 2. So that would be a 15. Okay, so anytime you see the word group or committee, you know automatically it's a combination. Don't try to do it as a permutation, otherwise you'll get the wrong answer. So suppose 20 students will be separated into 3 smaller groups. Group A consists of 5, Group B consists of 8, Group C consists of 7. How many different ways can this be done? So how would I choose the first group? How many people do I have to choose from? I have 20 to choose from, and I need to choose 5. How would I choose the second group? Huh? No, it's not 20C7. Think about this in a second. I have 20 kids in here. I put 5 people in a group. Am I going to choose them again? No, they're out. Now I have these people to do the other 2 groups. What's going to happen with the last group? They don't get a choice. They're just in a group together, right? Okay, so what is this going to be? 15C7. And the last group gets the leftover. So that would be... Oh, sorry, 8. And then it would be 7C7. And what was 7C7 equal to again? 1. Do you see the last group doesn't get a choice? Let's multiply and get the answer here. Get out the calculator. If you toggle left on to probability, it's way faster than trying to go right several times. $99,768,240. Everybody get that? How many committees of 3 girls and 5 boys can be made of a class of 15 girls, 20 boys if there's no restrictions? So, how do I choose the girls? 15, choose 3. And then how do I choose the boys? 20, choose 5. So for every girl group, I have a multiply effect for the boys. That's why it's going to be huge, right? The only time you add is cases. These aren't 2 cases. This is 1 case. Okay. So now, Rita, John, and Adam must be on the committee. I guess they run the show, so they have to be on the committee. So now, how am I going to get a committee of 3 girls and 5 boys? So Rita is a girl, just in case you don't know, and John and Adam are boys. Okay, so let's do the girls first. 14C2, very good. And how would we choose the boys? 18C3, very good. Does everybody see why it's those numbers? Once you do it once, you'll figure these things out. $74,256. Did everybody get that? Yeah. Okay, so now we're going to have a committee of 5 with at least 3 girls on the committee. So how are we going to do that? We have 2 cases? I beg to differ. We do have cases, but not 2. 3, what would the 3 cases be? 3 girls and 2 boys, yes? Case 2 would be 4 girls, 1 boy on the committee. And case 3 would be all girls. That would be 5, right? Okay, so how do I choose 3 girls? $15, choose 3 times 20, choose 5. Yes, and I already calculated that. That was 7,054,320 from the A question. Yes, so I have to recalculate that. And by the way, these are all subscripts. 15C 3 times 20C2. 86,450. So the next one would be 15, choose 4 times 20, choose 1. Does everybody know what 20 choose 1 is? 20. It just saves time if you understand those things, right? Instead of going through your calculator keystrokes. So you get 27,300. And then this would be 15, choose 5. $3,000. And what do we do with cases? Add them all up. $116,753. Anybody else get that? Does everybody know what a deck of cards consists of? 52 cards, 4 suits of 13 cards each. So if a cribbage hand consists of 6 cards, does everybody understand, unlike the video that we watched where they were saying the order was important, usually in a card game the order doesn't matter. You can switch your cards around, right? So this is a combination question. So how would I figure out how many different hands are possible? $52, choose 6. It's still going to be a big number, though. 2035850. So that's 20 million hands, essentially, right? Okay. How many crib hands would have exactly 3 kings? So how do you guarantee to have exactly 3 kings in your hand? You need to choose from only the kings to get the 3. So what would you do to get the 3 kings? 4, choose 3. There's only 4 kings. And then the remaining cards can't be kings because we want exactly 3 kings. So how many aren't kings? 48. And how many cards do I need to make a crib hand? 3 more. Okay, does anybody know what 4 choose 3 is equal to? What does 4 choose 3 equal? It's equal to 4. Very good. So you get 69,184. So back before the curriculum change, they used to have probability as part of this as well. And so then they would change it into what is the probability of getting exactly 3 kings in a cribbage hand. So then it would just be this over this, right? So like B over A. Okay, I need to find a crib hand that has no face cards. Does everybody know what a face card is? Jack, Queen, King. How many are there? There's 12 face cards, right? 12. So how many, to guarantee not get any face cards, I need only the pile of non-face cards. So how many would there be? 40. C? No, not 12. A crib hand is only 6. So 3838380. So 3,838,380. A combination lock uses 3 different numbers from 1 to 39 for any combination. How many combinations are possible for this lock?
Probably a lot.
I'll figure it out. I'll give you a second to figure it out. A combination lock is not really a combination. It is a permutation. So let's be all math geeks and start calling our combination locks permutation locks, because that's actually the correct mathematical term for it. This was a question on the provincial exam, is why I threw it on there, so let's do it. So what would NC6 be changed to? N factorial divided by n minus 6 factorial, 6 factorial. Then we have a 3, it's just a 3. And then what would n minus 2c4 be changed to? N minus 2 factorial divided by n minus 6 factorial, 4 factorial. Okay, so how are we going to do this? I would get all the factorials on all the n factorials on one side and all the numbers on the other side. This is why cross multiplying better be your friend here. So 6 goes up, this goes down, this goes up. So we get n factorial times n minus 6 factorial over n minus 6 factorial n minus 2 factorial equals 3 times 6 factorial over 4 factorial. Again, cross multiplying should be your friend by now. These cancel. Does everybody see? They're exactly the same. What does n factorial over n minus 2 factorial simplify to be? Yeah, I'm just going to write it as n times n minus 1 first, because most people might not know it's n squared minus n. And then what does this simplify to be? Yeah, you could say 90 if you want. I'm just going to go 6 times 5, just so you know. Okay, so now I'm going to move everything over. So n squared minus n minus 90 equals 0. Yes? What does this factor to be? 10 and 9. So minus 10 plus 9 equals 0. So what does n equal? 10 and negative 9. And what do I do with the negative 9? I reject it because it's not a natural number.